scientific advisor at RTE, the French ESO. So we are operating and developing the grid, and we have the owner of the grid. So we own the grid from 63 kV to 400 kV in France. We are the unique TSO in France. So thank you for giving me the opportunity to share with you some idea about this ongoing evolution, perhaps a revolution. So my talk will not focus directly on the classical problem of intermittency of renewable energy and perhaps their zero marginal cost, but more on the fact that digitalization could help to perform this energy transition, and we try to get off some beaten tracks and to give you some idea on another dimension of the problem. So yes, yes, in 2003, yes, this was this quotation there. In 2003, the National Academy of Engineering in US told us that large power systems are perhaps the most complex machine ever built by mankind. And I believe that these systems are becoming even more complex. So let me share with you some idea about that. So yes, so indeed, the power systems are changing a lot. This is perhaps a revolution for me, similar to the one from digital to analog in a telecommunication system. So we are used to explain that Tesla and Edison were able to understand how our system was working. But I believe that it's less and less true with the massive integration of smaller units and connected through power electronics to the grid. Yes, so our systems are really in transformation, and they are more becoming a cyber-physical system of systems. So the behavior of the system is more and more dependent on the control system rather than the first principle of physics that are more hidden by some interfaces through power electronics. So this embedded control and digital solution are facilitating the energy transition. And in fact, the energy transition pushes toward more dispersed generation and more distributed control. So now the problem is more to manage a large population of agent and device with some partial autonomy. So we have to think about that. So we have to pay attention. So in the past, the cyber layer was more something for optimizing the system and managing the flow of money. and the physical layer was more based on some physical rules and some very simple analog local control. So we're living this old world, perhaps not like this tightrope walkers, I hope. So then the system is becoming a bit different. So we have this blue cyber layer that is going down the physics. By this I mean that we have a lot of power electronics that we can control, so we can do a lot. So we have a lot of freedom, but this could impact the stability and the safety of the system. And of course, we can also add something to anticipate some very nasty situation. For example, if you have a lot of offshore wind, we have to anticipate some storm for a possible tripping of many of them. Of course, the classical layer of optimization is changing a lot. We can have these people, this active prosumer, and perhaps some aggregators that can change a lot the optimization of the system. But I believe that we never use this peer-to-peer transaction and blockchain, for example, to ensure the security and, for example, to protect a transformer for all overload. This transformer could explode. It's not something that is just about market. It's about physical impact on the system with something that is very important. So as a conclusion, I believe that 100% of renewable energy for electricity is technically possible, taking advantage of well-designed digital solution. By well-designed, I mean we have to understand the difference between the yellow and the blue cyber layer that are very different for me. One is more about optimality, the second one is more feasibility and technical problem. So this is what I have.
Thank you very much. Any immediate comments or questions? If not, then I would suggest we just move on.
Thank you.
Very much.